This is part 2, History of AI of the series AI for Everyone. Here is a concise timeline for the AI. In 1950, Alan Turing publishes Computing Machinery and Intelligence, proposing the Turing test to determine machine intelligence. In 1956, Dartmouth Conference was held and the term artificial intelligence is coined, marking the formal birth of AI as a field. In 1958, Frank Rosenblatt introduced the perceptron, an early neural network model that could learn simple tasks. It showed that a machine could learn from data by adjusting weights, though only for linearly separable tasks. Between 1979 to 1980, there was a boom of expert system. These are not using neural networks, but an extensive rule-based coding that is specific to a particular field. Systems like MySyn used in medical diagnosis and Dendral used for chemical analysis are some examples. This was also a time where funding for AI dried up and is also known as the decade of AI winter. This happened because Minsky mathematically proved that single-layer perceptron cannot handle XOR function. Remember logic gates from our previous chapters of electronic gates? The another reason for AI winter was that it was very hard to train the MLP or multi-layer perceptron. In 1986, a key turning point occurred when David Rumelhart, Geoffrey Hinton, and Ronald Williams published their seminal paper on the backpropagation algorithm. They demonstrated how multi-layer perceptron could be trained by propagating error signals backward from the output to adjust weights layer by layer. His effectively solved the training problem for multi-layer networks. While backpropagation would not immediately spark mainstream success, it provided the essential mechanism for deeper architectures. In 1997, IBM's Deep Blue defeats Garry Kasparov, a reigning world chess champion, highlighting AI's strategic reasoning abilities. Deep Blue was primarily based on expert systems, not neural networks like multi-layer perceptron. Deep Blue relied on a rule-based system combined with heuristic evaluation functions tailored for chess. In 2006, Geoffrey Hinton introduces deep belief networks, sparking renewed interest in deep learning. Hinton introduced a layer-by-layer pre-training approach using restricted Boltzmann machines or RBMs that overcame difficulties in training deep structures all at once. This work led to renewed excitement in deep architectures, networks with many hidden layers, culminating in an explosion of research and industrial interest. In 2012, inspired by DBN techniques, AlexNet by Krzyzewski, Sutskever, and Hinton wins the ImageNet competition, demonstrating the power of convolutional neural networks, CNNs. Deep learning advances extend to recurrent neural networks, RNNs, followed by long short-term memory, LSTM, and gated recurrent units, GRUs. Between 2015 and 2002, rapid advances in happen like image recognition AI achieves near-human performance. Speech recognition, AI systems achieve human parity, e.g. Google's WaveNet machine translation. Systems like Google Translate become highly accurate. In 2017, transformer architecture was introduced by Vaswani et al. With the paper, Attention is All You Need, laying the groundwork for modern language models. Between 2019 and 2020, OpenAI released GPT-2, a transformer-based language model that could generate surprisingly coherent text. Then GPT-3 arrived, with 175 billion parameters, spurring creative uses in code generation, writing, and more. Period between 2021 to 2022 was the golden period for generative AI, as it just took of the ground, and many rapid progress were made when many advanced LLM were released, each beating others in short span of time. Now let's begin our journey into the fascinating world of artificial intelligence, AI. You'll be able to correlate AI concepts with our previous examples, such as Morse code, barcodes, binary numbers, and GPS navigation. These foundational ideas will help illustrate the engineering mindset and how it has led to groundbreaking advancements in AI. Understanding AI. AI is a broad, overarching term used to describe a field of computer science that seeks to create intelligent machines capable of replicating or even exceeding human intelligence. The first major step toward AI was machine learning, ML, which enabled machines to learn patterns and make decisions without being explicitly programmed for each task. Early machine learning models were built on mathematical algorithms that relied on feature engineering, a process in which human experts identified and designed input variables to represent data effectively. These ML models were task-specific, lightweight, and efficient, requiring minimal computing power for inference. Then came the era of deep learning, which introduced multi-layered neural networks capable of automatically learning representations of data. Unlike traditional machine learning, deep learning reduced the need for manual feature engineering by allowing the network to learn patterns on its own. However, these systems required large amounts of computational power and huge volumes of curated data to train effectively. The age of generative AI. The latest advancement in AI is generative AI, a class of models capable of generating text, images, audio, and other content based on given prompts. These models are still based on neural networks, but they are significantly larger, leading to the term large language models, LLMs. These models require massive computational resources, typically relying on specialized hardware such as GPUs, graphics processing units, and TPUs, tensor processing units. This high computational cost makes them inaccessible to the average user, as they demand powerful infrastructure for training and inference. Unlike traditional machine learning, generative AI and LLMs have largely eliminated the need for manual feature engineering. Instead, they automatically learn complex patterns from vast datasets, making them highly versatile across multiple tasks. One of the most important architectures behind generative AI is the transformer architecture, which powers many state-of-the-art AI models today. Here is a 60,000 feet overview of World of AI. You can note down some of the important algorithms used in each type of learning. Here is a detailed breakdown of different types of machine learning and their associated algorithms. If you intend to build a career in machine learning, this roadmap can help you track your learning progress. As you can see from the chart, early machine learning models relied on statistical inference to make decisions and extract patterns. This is represented in the top section of the chart, which also includes reinforcement learning. However, modern machine learning has evolved to incorporate neural networks, enabling more sophisticated AI capabilities. Statistical inference in machine learning is primarily categorized into supervised learning. Models learn from labeled data. Unsupervised learning. Models find patterns in unlabeled data. In this video, our primary focus will be on generative AI and neural networks. However, I am showcasing the entire machine learning landscape to provide a comprehensive understanding for those who want to learn the technology thoroughly